What if I told you that in the very first moments after the Big Bang, the universe expanded faster than the speed of light? Quite a brain twister, isn't it? Yet that's exactly what cosmic inflation is all about. It's a theory that speaks of a universe that, in its earliest moments, underwent an exponential expansion, growing at a pace that outstripped even light speed. Imagine a balloon. Now, picture that balloon inflating at an unimaginable speed, expanding in all directions simultaneously. That's what our universe did, according to the cosmic inflation theory. This theory is a crucial cog in the Big Bang Theory's machinery. Without cosmic inflation, the Big Bang Theory would struggle to explain why the universe appears to be so homogeneous and isotropic. Cosmic inflation also plays a significant role in shaping the universe as we know it. It helps explain why distant parts of the universe have similar properties, even though they are too far apart to have ever been in contact. It's like two people on opposite ends of the world having the same thoughts at the same time without ever having met. Cosmic inflation, in its essence, is a theory of origins. It's a glimpse into the very first moments of the universe, a window into the birth of space and time. Now let's delve into the top 10 theories that attempt to explain this phenomenal event. Kicking off our countdown at number 10 is the chaotic inflation theory. Picture a universe that's not just a one-time event, but an eternal self-reproducing entity. That's the heart of the chaotic inflation theory. This theory suggests that the universe undergoes constant, rapid expansion, creating an infinite number of bubble universes in the process. Each of these bubbles represents a different region of space, born from an initial state of high energy. As these regions expand, they experience a decrease in energy density, leading to the formation of galaxies, stars, and eventually, life as we know it. But here's the twist. Each bubble universe could have different physical properties, governed by different laws of physics. It's a mind-bending concept, isn't it? An ever-expanding, ever-changing universe that's constantly giving birth to new universes. While this theory is fascinating, it's just one of many attempts to make sense of cosmic inflation. At number 9, we have the new inflation theory. This theory suggests that the cosmos expanded at a slower, more controlled rate than previously thought. Instead of a wild, chaotic growth spurt, the universe inflated more like a leisurely balloon being filled with air. This theory emerged in the early 80s, positing that the universe didn't just inflate and stop. Instead, it proposed a period of slower, more steady expansion that followed the initial inflationary period. This slower expansion could explain why the universe appears to be so uniform and homogeneous, as it allowed for better distribution of matter and energy. The new inflation theory also suggests that the universe inflated from a state of high energy, known as a false vacuum. This state is unstable and eventually decays, leading to the slower expansion we see today. Though it offers a different perspective, it still leaves many questions unanswered. Questions such as what triggered the initial inflation and what exactly is the nature of the so-called false vacuum. Next up at number 8 is the Curvaton Scenario. In our cosmic journey to understand the universe's early rapid expansion, we encounter this compelling theory. The Curvaton Scenario introduces an additional scalar field into the inflationary model. This scalar field, known as the Curvaton, is believed to be responsible for the density fluctuations we observe in the cosmic microwave background. In simpler terms, the Curvaton Scenario suggests that the universe's initial expansion wasn't perfectly smooth. There were slight variations in density, like the ripples on a pond's surface. These tiny differences, amplified by the universe's expansion, eventually led to the formation of galaxies, stars, and everything else we see in the cosmos today. The Curvaton Scenario adds a layer of complexity to our understanding of cosmic inflation. It bridges the gap between the macroscopic universe we see today and the microscopic quantum world of the universe's earliest moments. While this theory is intriguing, the search for answers continues. Coming in at number 7 is the Higgs inflation theory. This theory is a fascinating blend of cosmology and particle physics. It involves the Higgs field, an energy field thought to exist throughout the universe. It's named after physicist Peter Higgs, who predicted its existence. According to this theory, the Higgs field played a crucial role in the universe's inflationary period. The Higgs particle, sometimes referred to as the God particle, is associated with this field. The Higgs inflation theory suggests that these particles in their high-energy state could have driven the rapid expansion of the universe in its earliest moments. In other words, the universe might have hitched a ride on a wave of Higgs particles. The Higgs inflation theory is fascinating because it ties together the micro and macro scales of our universe, from the tiniest particles to the vast cosmos. This theory adds another layer to our understanding, but the mystery of cosmic inflation persists. Halfway through our countdown, at number 6, we have the warm inflation theory. This theory is quite fascinating as it introduces the idea of a hot universe during inflation. While most inflationary theories propose a cold universe, the warm inflation theory begs to differ. According to this theory, the universe was not in a supercooled state during the inflationary period. Instead, it was warm, thanks to the constant interaction and friction between particles. This warmth is believed to have generated a constant release of radiation, keeping the universe heated up. The concept of a warm universe during inflation has profound implications. It suggests that the universe didn't have to go through a reheating phase after inflation, a process that many other theories propose. It also provides a unique perspective on the generation of cosmic structures. So, the warm inflation theory is a hot take on the universe's early moments, challenging conventional views. While this theory warms things up, there's still more to explore. Cracking the top 5, we have the eternal inflation theory. Now, this is where things get really interesting. The eternal inflation theory takes the concept of inflation and runs wild with it. It proposes that inflation, the rapid expansion of the universe we've been discussing, never truly comes to a halt. Imagine a universe that's forever growing, forever expanding, and forever inflating. That's what the eternal inflation theory suggests. It's like a never-ending cosmic dance where the universe continues to grow at an exponential rate, giving rise to infinite bubble universes within a greater multiverse. This theory, as mind-bending as it may sound, actually stems from the math of inflation itself. The equations reveal that once inflation starts, it's incredibly difficult to stop everywhere at once. There are always regions where the expansion continues, creating a cosmic patchwork of inflating and non-inflating regions. This theory takes us into the realm of the infinite, but our journey isn't over yet. At number 4, we have the slow roll inflation theory. This concept takes a somewhat contrary approach to the widely accepted theories of hyper-fast cosmic expansion. The slow roll inflation theory suggests that the universe didn't speed up in the blink of an eye, but rather, it gradually expanded at a slower, more controlled pace. Much like a car pulling out of a driveway, the universe, according to this theory, didn't just slam on the gas pedal. Instead, it carefully backed out, slowly increased its speed over time, and then finally hit the highway of cosmic expansion. This theory allows for a more gradual transition from the dense, hot early universe to the large, cool cosmos we see today. Critics argue that this theory lacks the dramatic flair of its counterparts, but supporters appreciate its steady, measured approach to cosmic inflation. While this theory slows things down, we're still racing towards the number 1 spot. Just missing the top spot at number 3, we have the Starobinsky Model. This theory, proposed by Russian physicist Alexei Starobinsky, is a fascinating approach to cosmic inflation. It's not just about the rapid expansion of the universe, but also about the intriguing quantum corrections to general relativity. You see, in the Starobinsky model, the universe doesn't inflate due to a scalar field, as in many other theories. Instead, it's the quantum effects of gravity that drive the expansion. Starobinsky suggested that these quantum effects could lead to a modification of Einstein's equations of general relativity. This, in turn, would give rise to a period of accelerated expansion in the early universe. This model has been lauded for its elegance and simplicity, as it doesn't require the introduction of new fields or particles. It simply adds a quantum twist to our understanding of the universe's inflation. But hold on to your hats, folks, because we're not done yet. At the runner-up spot, we have the pre-Big Bang Scenario. This theory takes us on an intriguing journey to a time before the Big Bang. One might wonder, How could anything exist before the birth of the universe? The pre-Big Bang scenario suggests that our universe is cyclic, with each cycle beginning and ending in a singularity, commonly known as the Big Bang and Big Crunch. It posits that a previous universe, similar to ours, contracted into a singularity, causing an immense release of energy that we perceive as the Big Bang. This cycle of universal birth and death continues indefinitely, with each iteration potentially having different physical laws. This theory challenges the traditional view that time and space were created at the Big Bang, suggesting instead that they existed before and will continue to exist after our universe. It's a mind-boggling concept that pushes the boundaries of our comprehension. This theory takes us back to the beginning, but there's still one theory left. And finally, at number 1, we have the inflationary multiverse theory. The grandest of all cosmic inflation theories, this one takes the cake by suggesting that our universe is simply one of many. Yes, you heard that right. We might be living in a multiverse. So what is the inflationary multiverse theory all about? Well, it's based on the concept of eternal inflation. This theory suggests that inflation didn't stop everywhere at the same time. Instead, it stopped in patches. These patches, where inflation ceased, became individual universes, including our own. But outside these patches, inflation is still going on, forever creating new universes. Now imagine this. Each of these universes has its own laws of physics, its own constants, and its own cosmic story. Some might be similar to ours, while others could be radically different. The mind-boggling idea is that there could be an infinite number of these universes, each existing in its own bubble within the cosmic foam of the multiverse. But here's the catch. While this theory is fascinating, it's also highly speculative. We have no direct evidence of these other universes or even of the multiverse itself. It's a hypothesis that pushes the boundaries of our understanding and challenges us to rethink our place in the cosmos. This theory might top our list, but the mysteries of cosmic inflation are far from solved. Our quest to understand the universe and perhaps the multiverse continues. From eternal inflation to multiverses, these theories represent our best attempts to understand the universe's rapid expansion in its earliest moments. We've journeyed through the chaotic landscapes of the chaotic inflation theory and pondered the possibilities of the new inflation theory. We've navigated the curves of the Curvaton Scenario and explored the potential of the Higgs inflation theory. We warmed up to the warm inflation theory, delved into the unending expanses of the eternal inflation theory, and took time to slow down with the slow roll inflation theory. We've studied the intricate Starobinsky Model and revisited the dawn of time with the pre-Big Bang scenario. Lastly, we've contemplated the mind-bending concept of the inflationary multiverse theory. Each of these theories, in its own unique way, attempts to shed light on the enigma that is cosmic inflation. While we have yet to unravel all the secrets, every theory brings us one step closer to understanding our cosmic origins. Before we bring this cosmic journey to an end, we'd like to invite you on an ongoing voyage of discovery. If you've enjoyed exploring the universe with us, don't forget to hit that like button. It's a universal sign of appreciation. It's shaped like a thumbs-up symbol just below this video. Have an inflation theory that you find particularly fascinating or a question about something we've discussed. Feel free to share your thoughts in the comment box. It's a great way for us to learn from each other. To ensure that you don't miss any future trips through the cosmos, click the subscribe button. It's an easy way to stay updated and join our community of curious minds. And if you think others might enjoy this journey as much as you have, don't hesitate to share this video. You'll find the share icon below. It looks like a curved arrow. Remember, every like, comment, subscription, and share contributes to our collective understanding of the universe. So let's continue this cosmic journey together. Until next time, keep exploring.